Go Language Programming, Chapter 2, Unit 5. Function parameters as passed by value. So now there is in most of the programming languages, there's a concept of passing the parameters to functions as passed by value or passed by reference or passed by pointers. Okay, so in this we are talking about when we what happens when you pass a parameter to a function by value. Okay, so pass by value gets the copy of parameter, and therefore change will not affect the original parameter. So that's what it happens. It is going to be always be a copy. So when you make a change within the body of a function to that parameter, the data on that parameter, and the call returns back to the caller, nothing will be changed. So when function call is returned back to the caller, the value of a parameter will not be changed. Okay, that's because the parameter was passed by value. So let's go over this example 2-18. We have a package main because we want to be able to execute this code, and then within this code we import the fmt package, and then we have a function. We declare our own function with the func keyword add one. Okay, so that's the function name, which takes the one parameter, as you can see right here, which is the parameter. That means it's going to be passed by value. Okay, and the return type of the function is going to be a int right here. This is a return type. So every time that we want to return something, of course the function body will have a return statement, but you have to declare a return type right after the parameter list. Okay, and then before the body of the function starts, which with the curly braces, which should be in the same line as the function name. And then within the body of the function we have this parameter used, num. Okay, so we say num plus 1. Whatever the num was passed, we just add that 1 to it and assign back to the num, and then return the num. Okay, that's what we are doing. So we are returning the num. Now we're going to be calling this add one function within the body of the main function. So let's look at the main function, how the body looks like. So we declare a main at line number 10 with the keyword func, and the body will have or the body will start with the left curly braces on the same line as the function name, and it will end at line number 20. And within the body, very first thing at line number 11 we do is declare a days variable, which basically for which we are using a colon equals to. That means we are doing a short declaration. Okay, and initializing the data to it. So the compiler knows that this data is of type int, so the variable will automatically become of type int. Compiler will declare this variable as type int. And then within the print line, we are basically displaying the data, which is 3. So it should print 3, and then we are passing this days variable to add 1. Okay, so when we pass it, the call of add one, and then we pass this days, the original value of the days will not change. Okay, so the original value of days is 3. It will not change even though when we make a call to it. Okay, so when the call returns back, the return value, we will get one more, because we are that's what we are doing within the function body, and we are returning some value, uh, and that value will be one more than what we passed. So that is a right way. But we also wanted to be able to change this the data within the days. But it since we this function is taking the parameter passed by value, this is not going to be changed. Okay, so that's how the pass by value works. It won't let you change the data. Function function parameters as a pointer. So in this next slide, that's what we're going to go over. So now the parameter of the function will have a basically will have or will be able to take the addresses. Okay, so function parameters must know the memory address of the pass parameter. So that means the parameter must be declared as of type pointer. Okay, the pass variable address. So when you are calling the function and passing some variable, you must pass the address either by taking the address with the n percent, uh, um, uh, and then pass that parameter and declare the function parameter as a pointer type. Okay, so that's how it will know that it is an address that it is receiving as a from the parameter. So when you do that, basically, then the cost of passing the address is only 8 bytes. So it's pretty low. So even if you, like, for example, you use some big data structures and have the function parameter as a pointer type, and yet all you have to do is to pass the address of that big data structure, and it's still only be using the 8 bytes, okay, of memory. So let's look at this example. In this example, on number 2-19, basically we have a package main. That means we want to be able to compile this code and run it, and then we import the FMT package, and then we are creating the function modify, okay, with func keyword. And notice that it has a function parameter as of type function parameter as of type integer. Okay, pointed to an integer. That's what it is. And then within the body of the function, this parameter name is a ptr. I'm dereferencing it and putting the data, some different data than what it was passed. So let's see what happens here. So in this case, what we have is we have a memory that will be created, okay, num, and it will have 58 in there, and then it probably will be created at some address location 1000. And then when we print it at line number 12, all it is going to do is to print this value, okay, 58. Now at line number 14, we create a pointer variable. Okay, so pointer variable, basically we create it, that will be created at some address location, and the name will be ptr num, and then we put the address 1000, okay, right here, and we are using a short declaration that means colon equals to, the compiler automatically will figure out that, hey, we are taking the address of the variable num and initializing it to this ptr num. So it will create the ptr num as a pointer, okay, so it can hold the address. So that's the compiler's job. Now modify function which takes the pointer, we are passing the ptr num. So now when we pass the ptr num, within the ptr num we are actually passing this ptr num, this parameter will be holding the address. Which address it will be holding? It will be holding the this address uh, 1000, okay. So 1000 address will be in this ptr, and we are doing the dereferencing of 1000. So dereferencing of 1000 will allow us to write this new data to the same memory location that was already created, okay. So that's what this function will do. It will let us write this data which is within the function body, because we are telling it where to write this data, okay. And we are making sure that we do the dereferencing of that address that was passed to the function. Okay, the address was passed is 1000. And then, when we come out of this function modify and print num, now the value of num is going to be 55 right here. Okay, so it's no longer going to be 58 anymore. Okay. So let's look at another example relating to returning a pointer from the function. So returning a pointer content from a function. So of course, to do that, you will use a return statement. Okay. So in this example, which is 2-20, we will go over how that is done. So we have a package main, so we can compile this code and run it, and we import this fmt package, so we can use a print line function from it. And within this code, we are creating our own function add one, okay, and the parameter of that function is of a pointer type, okay, a pointer to an integer, and the return type is integer as well. So basically, when we return num, it is going to be returning the contents of whatever the address that we pass, because this parameter that since it's a pointer type parameter, that means it can only hold the address, so we will be passing some address to it, okay. And after passing the address, we do the dereferencing of that address to get the data. And in this case, we are dereferencing it, adding one to that data, okay, and then writing it back to the same memory. And then we are dereferencing that address and passing the contents of that address. So in the main, what we do is we declare a variable with a short declaration with a colon equals to and initialize with the integer 3. So now the days will be of type integer assigned by the compiler automatically. and then we are using a print line function from the FMT package to display what what value the days variable has, and then um, we are calling the add one function, and passing the address of the days. So when we pass the address of the days, basically that address will come to this parameter, and we are within the body, we are dereferencing that address and actually modifying the value at that address. Okay, so that's how it is doing. And then when the calls come back to the caller, which a caller is the main, then this add function will return the contents of that memory location. In our case, the memory location will be where the days is located. So basically, the value of that days will be assigned to the new day. Okay, because we are creating the new day as a variable, regular variable, in a short declaration with the colon equals to. Okay, and when we print out the new days, it actually will print, 4, because the modification occurred within the body of the add one function. And then at line number 19, we are printing the days, so it will print 4 for that. Okay, and basically, in this case, this example shows us how the how the parameter of type pointer is passed to a function. Okay, and that concludes um, uh, unit 5, chapter 2.